Hey guys, welcome. Yeah, so first and foremost, may the Lord Jesus Christ be with you everywhere that you go, like he's always with me. And second is we already had examples 0 and 1 on solids of revolution, right? In particular, in example 0, we looked at big picture, the disk method, the washer method, and then the method of cylindrical shells, right? And example 1 was all dedicated to the disk method. And I thought the 3 problems we saw on the disk method in example 1 were sufficient. But then I encountered this peculiar problem that I thought I'd share here in this video. So this video is kind of an addendum to example 1 and therefore example 1.5, right? And so yeah, we're gonna look at this one peculiar problem on the disk method, but it kind of requires a segue. So technically I'm going to provide you 2, not 1. Here. I wanted to say 2 examples, not 1, but then like calling an example within an example, like a Russian doll within a Russian doll, but like let's get on with it. All right. So first our segue, right? And at some point I'll have to get a ruler because like I'm annoying about drawing or redrawing lines correctly or accurately. All right, so that's our y-axis, and let's say that this is our x-axis. It's not horizontal. All right, that's better. That is better. All right, this is better, kind of. It's got kinks, but whatever, we'll live. All right, so this is the x-axis. Now, so let's consider this curve, right? And let's say that this is y equals a half x squared, right? And let's say that we form our region. Well, yeah, pretend like this is 0, 0. You could see that I missed this spot as 0, 0, but just pretend that it is 0, 0. All right. And we're gonna revolve our region. Our region isn't formed yet. We're gonna revolve our region about this line. Can you see that? Can you see that? I can't. I can, but it's faded. I'll do it in black. So this green marker. Okay. So let's say that we're revolving about the horizontal line, this line, and this line, let's say, is y equals 2. So clearly you can see that my region is like this region right here, right? Okay, cool. All right, now let's keep it simple. We're doing disk method and we're revolving about a horizontal line, and we know that horizontal line means that we write a dx, but otherwise the disk method is very simple. It's pi r squared dx. Why so distant? Okay, so we're still gonna use that formula, right? It's horizontal line, so we stick to that. All right. But our solid, what does that look like? Well, if this is y equals 2, if a key is y equals y equals 4, then first, after 180 degree revolution, our region will look again. Our region will look like this, right? Kind of. Yeah. Well, like use your imagination to make it like more accurate. But our region, I'm sorry guys, our region is going to turn into look at this. I'm gonna help you out with some symmetry. Our region is going to look like this after 180 degree revolution, right? Pause. Okay. and so our solid is going to look like this, right? Like, so this is like a circular end cap to our solid. So it's still a paraboloid, our solid, right? Yeah. Okay, and so perhaps I draw a cross section of our solid in blue, but you can clearly see this is supposed to be a circle, right? A blue circle. So I've drawn 2 cross sections. Well, technically this one is like an end cap. You get it. Okay, so it's all about R, right? Because once we figure out what R is, and we need R in terms of X, since we have a dx and we're revolving about a horizontal line. Yeah, so it's all about R. So what is R? Well, R is clearly, and on this cross section, R is this vertical line, right? So let me like say that is R. But what exactly is that? Well, notice that the distance from this horizontal line to the x-axis, it's 2 everywhere. It's 2, including like on top of this blue R that I drew, it'd be 2. Well, I don't want to draw it on top of our blue R, but clearly the distance from here to here is 2. It's 2 here. It's 2 here. It's 2 here. Okay, I don't want to be abusive. But then, what is that green marker would have been really useful just about now. What is this distance right here? In other words, like our radius in blue goes from here to here, and we know from here all the way here is 2. But what's this bit? This bit is the y value associated to this x, but that y value is 1/2 x squared. So I'm saying this little bit, right, this tiny bit right here, this bit is 1/2 x squared, the y value for this x. And it doesn't matter where the x is, like I could kind of similarly construct vertical lines, pieced up into like R, and then the rest of the way will always be 1/2 x squared. So I see what R is. R is equal to 2, the whole distance, minus this bit, minus 1/2 x squared. Yeah? Okay, so once you figured out what R is, it's done, because the rest of it is just like, can you like do binomials and integrate and stuff, right? Okay, so obviously our limits of integration are also pretty straightforward. We're going from 0, we're going along the x, so from 0 to whatever the x coordinate of this is, and that's not hard to figure out. We just set 1/2 x squared, the parabola, to equal the y value 2, and that'd get us the x coordinate of this point, right? In other words, what is that? So solving this gets us question mark. So I multiply by 2 on both sides, and I get x squared is equal to 4. And so that means x is equal to plus or minus 2, right? Obviously, I only looked at the parabola 1/2 x squared in the first quadrant, and so the minus 2 is no good to us. So I see question mark is 2. So I come here and I go, all right, 0 to 2. And otherwise, we've already written down our R, and that's 2 minus 1/2 x squared o squared dx. Okay, I'm only going to get you started on this because the rest of it is pretty straightforward. Foil this, right? So that's going to be 4, and then minus 2 times a negative half squared. No, positive half squared. I already accounted for it, the minus sign here with that. So basically I'm saying use the binomial a minus b squared. So a minus b squared is a squared minus 2ab plus b squared, where a is clearly 2 and b is 1/2 x squared. So at the end I'll have to write plus 1/4 x to the 4th, right? And this simplifies to a 2x squared in the middle, but it's minus 2x squared, and then dx here. So you ought to know how to finish this. And okay, all right, so the peculiar example, let's go with that one. All right. Okay, what is this peculiar example? It's a mystery. No, it's not. Yes, it is. No, it's not. Okay, so here it goes. So, good. I did well there. Whatever. We'll live. Okay, so x here, and then y here, right? Okay, so this is it. We're gonna take y equals negative 1/9 x squared. That's a parabola that starts at 0, 0 and faces down like this. It's kind of wide, right, because of the 1/9, and it's facing down because of the minus sign in front of the 1/9. And we're going to revolve this fella about the line y equals negative 1. So y equals -1 would be like right here, right? There's some asymmetry in this part. Sorry guys, I want to do better. Okay, that's better. Okay, so having too much fun. Yeah. When you're walking with the Lord, life is good. LG. Okay. All right. So there that goes, and we're revolving it about the line y equals -1. I see. So our solid is going to look like this, right? So like, let me try and do my best to mirror it, right? Like, it's not a good mirror, but whatever. Most mirrors aren't. Anytime I look at my face in the mirror, I always think I'm more handsome than the mirror says. Okay. So there that goes. And good mirror, bad mirror, good mirror. Okay. So there that is. And if I draw like one circular like cross section of our solid, this isn't quite a solid, obviously. This here is like 180-degree revolution of our region, but like it's actually a solid. Now it's gonna look like this when we cut it vertically, right? So I've drawn one circular cross section. That's all we really need. Okay. So again, we're revolving about a horizontal line. So we know that it's going to be pi and then integral and then it's r squared dx. Why don't we figure out the limits right now? So the limits are like where -1/9 x squared, the parabola, meets -1, the y value, right? This is why we set the y is equal so that we can figure out this coordinate and that coordinate, right? Okay, cool. Now, if I multiply both sides by -9, I'm going to get x squared is equal to 9, meaning x is equal to plus or minus 3, right? Okay, nice. So this here, right here is -3, right? And this here, the x coordinate is +3. Oh, okay, cool. Now, do you reckon, like I do, because I'm observant, no, that like I could just, instead of going from -3 to 3, I could just go from 0 to 3 and double it, because, well, our solid's volume on this part is identical to the volume on that part. So fine. I just heard you say fine, draw a cross section. Okay, here's another cross section on the right. So like, yeah, so the symmetry all the way, right? Okay. So why would I want to have 0 to 3 and double it as opposed to -3 to 3? Because plugging in 0 makes things easier, makes life easier, and je like that. Okay, so again, it's all about R, right? Now that we've done all this is the tricky part. We both need to focus. Okay, the tricky part is this, right? Like, so what is R? Clearly R is this, right? On this cross section, R is this, right? Okay, now remember this segue? You know what segues are good for, you know? Like, okay, so like the rest of the way would be this little bit. Okay, now you see this little bit, right? It's already a negative value. This little bit is -1/9 x squared, right? So the whole bit from here to here is 1, obviously. It's a distance, so it's not -1, because, right? Okay, it's a distance. So this is 1, and this here is R, right? This bit in blue is R. The rest of the way is -1/9 x squared. So where would you go wrong? Well, because you want to say 1 minus this bit. But if we do that, we're going to write 1 minus, we're going to have to write 1 minus -1/9 x squared. 1 plus 1/9 x squared. This is the wrong R. The correct R, right? The correct R is equal to 1 minus 1/9 x squared. In other words, because this bit, the y value associated to this x is already negative, you don't need to subtract 1 and this bit, because if you do, you end up saying plus. That's no good, because, well, what you just did is basically like go all the way to here and then a little bit more, like, and so you're saying r is from here to here. That's not true. R is just this bit, so it's 1 and then plus this bit, which is already negative. So correct r. Yeah. Okay, so that's the attention to detail, and I'm not very good at it. Okay, so now that we've figured out what r is, like, the rest is history, which is, well, 1 plus a ninth x squared is the correct r. So, like, as I did earlier, I'll help you out. 0 to 3, and then we said 1 plus ninth, no, sorry, 1 minus the r I had here was the correct r. I told you I'm not good at attention to detail. Okay, so here, right? Okay, and yeah, like, do you really need me to handhold beyond here? No, right? But I'll do a little bit more, so you're satisfied. So it's 1 squared and then minus 2 times 1 times 1 ninth x squared, and then plus 1/81st x to the 4th dx. I really do not enjoy doing monotonous algebra or arithmetic, so I am done. I hope you enjoyed this and keep watching. Take care.